All right, this is actually going to be two lessons in one, or a continuation of the last lesson and a new lesson. The new lesson deals with the average value of a function, which we're going to talk about in just a little bit. What I want to do first is deal with the fundamental theorem of calculus using trigonometry. And it's actually a lot easier in some cases than what we dealt with in the other. Now, I apologize for that last video. I was in a hurry and I needed to slow down. I didn't, so I made all kinds of stupid mistakes. So I'm in your camp as well. I rush, I don't do well. So hopefully I will not do that again. Anyway, moving on. So now we're going to look at some trig examples of the last lesson. So we're going to go to page 291, problem number 27. This is an integration from 0 to pi for the function of 1 plus sine x dx. Okay, so we're going to split that into two parts. One is dx is by itself, sine x dx is by itself. The integration of 1 is just plain x, and the integration of sine x, if you don't remember, look at the chart on page 250. That is negative cosine x. That's one you probably should remember, but if you don't, it's there in the chart for you to use. So we're going to take b minus a. So b is pi. So pi minus cosine of pi. Well, cosine of pi is 180 degrees, and that is going to be a negative 1 value. So that's pi minus negative 1. Then do the same thing with 0. So 0 minus the cosine of 0, or cosine of 0 is a positive 1. Remember, cosine curves start at 1 and then drop down. And then when it gets to pi, it's at the very bottom of that sinusoidal curve. So that's where the negative 1 comes from. So now we do this basic arithmetic here. That becomes pi plus 1 for this, minus the negative is plus 1. So the answer for number 27 is pi plus 2. Okay? Number 29, we're going from negative pi over 6 to pi over 6 for the secant squared x dx. Again, go to page 250 for the integration and differential chart we have there. And the integration of that is tangent of x. And we're going to take the tangent of x from negative pi over 6 to pi over 6. Well, pi over 6, if you do some quick calculation in your head or on your calculator, multiply that by 180 degrees per pi radian, that gives you 30 degrees. And if you know your chart for first quadrant angles or your circle, unit circle thing that you were probably taught, either one will give you an understanding that this is going to be positive because that's the first quadrant. 30 degrees is in the first quadrant. Negative pi over 6 is 330 degrees, or 11 pi over 6, which is in quadrant 4. We know that the tangent of x is positive in quadrant 1. Everything is tangent in quadrant 1. But in quadrant 4, the tangent is positive 3 and not 4. So that's a negative value. And so that becomes plus and positive, and you get 2 root 3 for the answer for that. Number 31, again, go back to page 250 for your secant data, tangent data, which is going to get the secant data when you do the go from integration to the derivative, doing the integral of it. So we pulled the 4 out right away, and this gave you this. And so now, because the derivation of that is, the integration of that is secant data. So secant data from negative pi over 3 to pi over 3. Well, pi over 3 is 60 degrees, and that is positive. Now, secant is the inverse of tangent. So, inverse of cosine. Cosine is positive in the first and second quadrants. No, first and fourth, no, sorry. Cosine I was thinking sine. Cosine is positive in the first and fourth quadrant, sine is first and second quadrant. And so we know that since this is a first quadrant angle and this is a fourth quadrant angle, they're both going to be positive. So, and we know that the cosine of 60 degrees is the same as the sine of 30 degrees, which is 1/2, or you just punch in the inverse of the sine of pi over 3, and that would be the cosine, inverse of the cosine of pi over 3, and that would be the secant of 3, which is 2. And we know they're both positive because that's the first one and the fourth one. So this is 2 minus 2 because you're subtracting b minus a, and that would give you 0 for an answer. All right, so that leads us up to the topic I had at the beginning, which is the average value of a function. Now, we talked about mean value theorem in the previous chapter, and this is kind of the same thing, that we can calculate the middle of a function that will split an area in half. And so the definition for the average value of a function dealing with an interval is 1 over b minus a for the integration from a to b of f of x dx. So we have to find the integration of f of x dx and multiply that by 1 over the difference between the two values in your definite interval. Okay? So we just got a little extra spice thrown in there. A little something we got to keep in mind here. So every time we start this problem, we're going to do this. Now, in 47, what they're asking you to do is to find the value of c that fits in this function. So what we're going to do is we're going to go ahead and come up with a value for x, for the function y rather, and find the x through that. So we're going to find the y value for this, and then we're going to plug that in for the equation. But they said they want the c value, which is between the two endpoints of your function. So we call that c, but it's the same thing as x. It's the next value, but it's within that range. And we're going to use that, and we're going to use the equation that says x squared and change it to a c squared and solve for c. So the first part is basically what we've done already. But we are going to have to throw in this average function to get the average. So we're going to take the integration of 4 minus x squared, and we're going to multiply that by this value right here. And we calculate that here as being 1/4. So we're going from -2 to 2, subtract 2 minus -2, it's a difference, not a sum, and that would be 4, so then we do 1/4 times this integration. And we go through the usual integration process. You can look at as we go through, but nothing too earth-shattering. But we do get an answer of 8/3. Okay? Now, once you've gone through all that stuff and get 8/3, you're not done. Unlike the last problems we dealt with, you were done. This time we are not. Now we need to find the value of c that's going to give us this average value. So, like I said, we replace x with c, so this becomes 4 minus c squared. And we set that equal to the answer we got here, 8/3. So I subtracted 4 to both sides, which is 12/3. And that gave me a -4/3. So I got negative c squared equals -4/3. Therefore, c squared equals 4/3. Did I have to take the square root of that? Now remember, to take the square root, you're getting 2 answers, not 1. You have to put the plus or minus value in there. The square root of 4 is 2. You got the square root of 3 in the denominator. You got to fix that so we don't have a radical denominator. Multiply top and bottom square root of 3. Type that into your calculator, and you get plus or minus 1.155. Okay? So, same process, just an extra step that deals with the average, and the same step, or when I said same procedure, with the kicker of having an average constant in there that has to modify that. Number 49 is the trig version of 47. So again, we have to find the average constant that we're going to be using for this, and that's the difference between A and B. That's pi minus 0 is pi in the denominator, so it's 1 over pi. So this becomes 1 over pi times the integration of that function right there. It should have dx after it, whatever. No, well, it'll go here. So we get the dx here with the sign, and we know that according to page 250, the integration of sine x is negative cosine x. The 1 over pi is a number, it's not a variable. Pi is, even though it's irrational, it is a constant. So we take that out, and this gives a negative cosine x here. We're going from 0 to pi. So this is going to be negative cosine of pi, which is right between the second and third quadrant. And we know that value is negative 1. And the negative, it's a negative 1, but then we have the negative of a negative 1, which makes that positive 1, minus the cosine of 0 is positive 1, but now you've got a negative cosine of 0, which is negative 1. You got 1 minus negative 1 equals, or times 1 over pi, which gives you 2 over pi. That is your value that you're going to plug into the function now, right here. You plug in 2 over pi for x, which is now your c. So sine of c is 2 over pi. In order to find out what c is, you have to take the inverse, or the what we call the arc sine of 2 over pi, make sure it's in radians, and that gives you 0.690. Now, we know that that is a first quadrant value. This 0.690 is less than 1.57, which is the 90-degree value. We also know that, and that's the only other option we have, since we know that the sign is positive in quadrant 1, quadrants 1 and 2, and they have to be within 0 and pi. We either have to find a second quadrant function, or if there isn't one, we're just done with that one value. Well, in this particular case, if we take pi minus 0.690, that will give us the second quadrant, because it's a reference angle. Now remember, reference angles, this is what we're talking about here. When you deal with reference angles like this, if the value of this angle right here is 0.690 radians, that is the reference angle, meaning how far away from the nearest x-axis it is. So we know that the second quadrant then is going to have 0.690 from this part of the x-axis. So this is going to be, whatever this is, minus 0.690. Well, what is that? Well, that's pi. This is 0, pi, 2 pi, 3 pi, and so on like that. The range is between 0 and 3 pi, and we are indeed going to be able to get that. So we just take pi minus 0.690, like I've done up there, and we get 2.451. So that's how you do averages for integral functions. Practice problems 28, 30, 32, 44, 46 on page 291. Have fun!